All right, welcome. So today we're going to start with chapter 8, which is sort of like the last little bit of what we're going to be covering, and that's series solutions to differential equations. So let's just look at a very simple one, or one we already know. So let's consider y prime equals kx with y of 0 given by y sub 0. Now, we already know the solution to this, or at least we should. Okay, if it's, this point, you should know how to solve this pretty simply. Let's just real quick as a refresher. dy dx equals kx. dy equals, that should be ky, my bad. So if you didn't know how to solve that, I mean, you should still be able to, but okay. Anyways, dy over y equals k dx. Okay, so that's going to give us natural log of y equals kx plus c. Y equals e to the kx times e to the c. So it's y sub 0 e to the kx. So we already know that solution, but we're going to do it via series, okay? So let's go ahead and let's start. So we're going to assume that we have some series solution. Okay, so we assume that y of x equals the sum. Okay, we're going to go ahead, we're going to start it from k equaling 0, or n equaling 0, let's use. So we assume that we have the sum from n equaling 0 to infinity, a sub n x to the power of n. Okay, and then we're going to plug that in to the equation and solve. Okay, so what do I mean by that? Okay, so if y equals a sub n x to the n, the sum, that means y prime of x equals the sum, n goes from 0 to infinity, a sub n times n x to the n minus 1. Okay, now one of the things that we're going to notice is that we're going to get some things going away. This term is the same as n equaling 1 to infinity, a sub n times n x to the n minus 1. Okay, and why is that? Because this n, when n equals 0, is just 0. Okay, so the first term we can blow up. We can go away. Okay, but then we can also sort of shift it back. We're going to go ahead and shift it back, and we're going to put it sort of like put it on the same terms with this thing. Okay, so what we're going to do is then we're going to say this means this is the sum, n goes from 0 to infinity, and we're just going to shift everything up by 1. Okay, so the way I think about this is my first term here is a sub 1. So that means I'm going to need an a sub n plus 1. Okay, instead of n, it's going to be n plus 1. And instead of x to the n minus 1, it's going to be x to the n. Okay, so this is our y of x here. And this is what we're going to use for y prime of x. Okay, now we're going to go back to the equation, to the differential equation. Okay, so we're back at the differential equation. And so we're going to look. We're going to say, okay, y prime equals k times y. Or more likely, we're going to write, well, that's fine. Y prime equals k times y. So we're going to get the sum, n goes from 0 to infinity, a sub n plus 1, n plus 1, x to the n equals, now we're going to get on the other side, we're going to get k times the sum n equals 0 to infinity, a sub n, x to the n. Okay, so we're going to go ahead and put these on the same side. So we're going to get the sum, n goes from 0 to infinity, a sub n plus 1, n plus 1, now minus k, a sub n, all of this multiplied by x to the n equals 0. Okay, so far so good. All right, now we're going to go ahead and we're going to solve for a sub n plus 1 in terms of a of n. So that means, so what I'm saying is that at each step, this is going to be 0. Okay, so an plus 1 times n plus 1 minus k a sub n equals 0. Okay, and this equation is called a recurrence relation. Okay, and basically the recurrence relation is a relationship between the terms of a series that are going to give you the solution. Okay, and to be perfectly honest, this is the way that in practice most differential equations are solved, at least as I've seen them. Okay, so this is actually something we're going to use a lot in your career. Okay, so our recurrence relation, we can write it now as an plus 1 equals k a sub n divided by n plus 1. Okay, that's also considered a recurrence relation. Okay, and now, since y of 0 equals y0, that's going to give us something. Okay, y. Let's take a look again at y of x. Y of x equaled sum, n goes from 0 to infinity, a sub n, x to the n, okay? Y of 0 equals y0. That means that a sub 0 equals y0, right? Because when you plug, sorry. Yes, sorry. So the n to the 0 term, that's 1. So the only term that's going to come out and give you anything is the a sub 0. So a sub 0 is y0. Okay, so that gives us our first term. We're going to go ahead and put that here. Okay, now let's do a sub 1. A sub 1 is going to be k, which is just a number. We don't even need to know what it is right now, or we don't even need to know it, but it is a number. It's not like a variable. It's not an index. It's going to be k times y0 divided by, now here, this n should match this n. So this is going to be divided by 1. Okay, a sub 2. This is going to be k times a1 divided by 2, which is k squared y0 divided by 2. a sub 3. This is k a sub 3 divided by now 3, which is k cubed y sub 0 divided by 3 times 2. Let's write it like that. Let's put a times 1 there as well. A sub 4, k times a sub, that should have been a sub 2 up here. Sorry about that. This one's a sub 3 divided by 4. So that's going to be k to the 4th y0 divided by 4 times 3 times 2 times 1. And we sort of are getting a pattern now. A sub n is k to the n y sub 0 divided by n factorial. Okay, you can see that pattern, I hope. So our y of x is the sum. N goes from 0 to infinity, k to the n over n factorial, x to the n times y0. But now that is actually just the Taylor series or the Maclaurin series for e to the x. Well, with the y0 there, and the e to the kx, right? No, let me write it this way. No, that's fine. Okay, you should know that, or you should remember that from Calc 2. Okay? All right, I'll see you in the next video. We're going to do sine and cosine, of course.